So if you wanted to create the polynomial values, okay, so I'll use some value of x, okay, so by creating, so these polynomial values can be easily create the polynomials which are below the 100 and then which are between the -4 and 4. So to get those values, I can use simply an expression like x equals to, I'm storing these values in a variable called x, okay, so x equals to is the inbuilt function lin space, okay, is a function of, so I need the values of the polynomial, so which is in between the -4 to 4, 100, okay, so up to 100 I need these values, okay, so now all these values will be stored in this, okay, so based on this we need to create some other variable like p vals, so to do the polynomial operation, okay, so to do the polynomial valuation for the valuation we have a inbuilt function like polyval, okay, so we will use that equals to polyval is an inbuilt function, is an inbuilt function, so which will evaluate the expression with the values among the -4 to 4 of 100 values, okay, so -4 నుంచి +4 వరకు ఉన్న 100 values ని evaluate చేస్తుంది అనమాట. సో ఇప్పుడు based on this expression, so whatever expression we have used this one, okay, so like x power 3 minus 1.5 x square minus 5.5 x plus 3. So based on this expression we are using the evaluation of the values, okay, so p comma x, okay, so this will give you the 100 values, okay, so 100 values will be given here, so you can see here, so the number of values, so those will be stored in a column, so you can have them so in a variable like p values, okay, so p value, and you can have I mean you can also read them, so by just simply calling p underscore vals, okay, so where I have stored them, so the same, so which you got, okay, so these values has been created, so now if you wanted to plot the graph, okay, so which is related to the x and p values, okay, so based on the -4 to the 100, I mean 100 values, so which are in the range of -4 to 4, now we'll get the number of the quotient values, okay, so here you can see by plotting plot x comma p value. So what the name I have given? Vals. Yes. Okay. So you'll get a graph of the values which we have taken from the this expression. Okay. The same one. Yes. So from -4 to +4. Okay, you get 100 values. Okay. So positive 30 and then negative 90 values. Okay. So whatever we have got in this, okay, so in this line space, okay, so in this line space, so we have got some number values. So based on the x cube minus 1.5 x okay, so below the, I mean 100 values from 4 to -4 to +4, okay, so that will give you the resultant plotting of the graph, okay, so clear, so you can produce like, so you can also have roots, okay, so if you wanted to find the roots of the expression which we have created, okay, so you can also just give like r equals to roots of p, okay, so you can see 3 minus 2 0 or the roots of the expression which we have created, okay, so now by using these roots, so you can also just I mean recreate related to the values, okay, so whatever we have gone for the, I mean we have created with the polynomial expression, okay, so let us see this, so these are all the roots, f of x equal to x minus 3 x plus 2 and then x minus 0.5, so after the poly function which is determined as a polynomial coefficient roots, okay, and then here, so you can also use like function called poly, okay, equals to poly of the r, okay, so you need to find it, so you can see that 1 minus 1.5 minus 5.5 3, so these are all the values or coefficients, okay, so coefficients which we have find based on the roots, okay, so roots based on the roots, if the roots are right then definitely coefficients will also will get as right. Okay, so this is about the evaluation related to the polynomials. So if you go for normal, I mean, addition, subtraction, multiplication operations, okay, arithmetic operations of the polynomial equations. Okay, so if you go for doing of them in a hand, okay, so by hand, if you wanted to do them, so what you need to do, you need to take f of x, some value or expression, and g of x, you need to take two values, right? So for doing of any of the operation like arithmetic or something which will result in some other value, so we need to have two expressions. Okay, so here two expressions is needed to be taken. So while we need to perform the addition, subtraction or something. Okay, so let us take an example of an expression like 4x for 4, sorry 5. We'll take order of 5 plus 3x power 4 plus 6x power 3 plus 2x power 2 plus x minus 10, and g of x equals to 3x square plus 4x plus 3. So take it as an example. So if you wanted to perform arithmetic operations on these two expressions of polynomial expressions, so it takes a lot of time to perform in a notebook, isn't it? Okay, so we need to take first, I mean, to evaluate these expressions, and then we need to take one by one, and then we need to individually evaluate by taking the roots and everything, and then we need to do that. Okay, so for doing it in MATLAB, so it is so simple to perform the polynomial. First, as I said, that we need to take the coefficients so of the expressions first. Okay, so we'll take like, so as we have taken f of x and g of x, we'll use those two. F equals to, what are the coefficients? 4, 3, 6, and 4, 3, 6, 2, 1, and minus 10, isn't it? And minus 10. Okay, so this is f. So which we can go for creating of the next, which is g. Okay, so g equals to 3, 4, sorry, yeah, 4, 3 only, right? So this is another expression quotients. So now we need to just have to do the operations like the arithmetic operations. So we need to perform arithmetic operations among them. F, sorry, f plus, so we'll take addition is equal to f plus g. So here we got some error because, so matrix dimensions must equal. So here, as you know that, so here only 3 variables are there, and then here 6 are there. So here the dimensions are not agreed. Okay, so for this purpose, what we will do, we'll create some other like with additional zeros. Okay, so 0, 0, 0, and g. So is the variable, I mean vector, which we have already created. Okay, so we'll add some additional zeros for balancing of this matrix. Okay, or vector. Okay, so yes, so now we have got this one, and then we can easily do like f plus g now. So now you can see that answer equal to 436557. Okay, minus 7. You can also perform multiplication. So here, for the purpose of multiplication, we don't have to use like star. So we need to use a function. Okay, so called conv, C-O-N-V. Okay, is a built-in function which we can use for performing of the multiplication. Okay, mul equals to here C-O-N-V of f comma g. Okay, so you can directly multiply them. Okay, enter. So it will take some time because this is little bigger value. Yeah, you have got the multiplied results. Okay, multiplication results. And then if you wanted to do the division, okay, so you can also use decon. Okay, so is a function so which will be used for the I mean division operation. Okay, so to perform the division operation among the vectors of coefficients. Okay, so of the this polynomial equations. Okay, so let's try this one also.